Okay, hello, welcome back, Year 12, or not welcome back, but I hope you had a good Easter anyway. Feel refreshed, ready to crack on with some maths. Right, I'm going to look through, this is question 5. I'm going to go through parts A, B and C, and then the main point that people said they got confused with was point D. I'll do a separate video on that. I'd just like us to double check that we fully understand how to set up the diagram for these pulley ones first. Right, so I'll read the question carefully. Two particles A and B, detailed here, A and B, have masses of 5m and km respectively, where k is less than 5. If k is less than 5, then I imagine when this is released from rest, because that's normally what they do, this will go down, this will go up. The particles are connected by a light inextensible string which passes over a fixed pulley. The system is held at rest with the string taut. Okay. The hanging parts of the string vertical with A and B at the same height. Okay, this bit's really important for part B, the same height. So this height here and this height here are exactly the same, okay, as shown in figure 4. The system is released from rest. That sounds important, so I know the initial velocity is 0. After release, A descends with acceleration of 1/4 g. Show that the tension in the string as A descends is 15/4 mg. Right, first thing I always have to do is make sure that this is clearly labelled. So I'm just going to put the weight of this particle here, which I know is the mass, is km. Therefore, this will be kmg. Right, this has a mass of 5m. Therefore, I know that the weight acting on this will be 5 mg. The tension will be acting against that. I have this tension here, this tension here. Then we have these tensions here, which essentially is the force acting on the pulley. What way did it say it was accelerating again? After release, A descends, A goes down with acceleration of 1/4 g. Okay, so A is going down. So all of the system is accelerating down with 1/4 g, or g over 4 if you wanted to say it like that. Therefore, because this is connected by a light inextensible string, I know that B will be ascending with an acceleration of 1/4 g. Okay, right. Show that the tension in the string as A descends is 15/4 mg. Okay, right. So I could look at the forces acting on A, or I could look at the forces acting on B. The reason I'm going to pick A over B is because this has got an unknown K in it. So I'm going to look at the forces acting on A. Let's just do that now. So I'm just going to draw a nice little box around A. Then I'm just going to say, I'm going to, for A, and then if it's accelerating downwards, I'm going to resolve downwards. So let's look at the resultant force. I know that I've got 5 mg is acting down. I've said down is positive. So I've got 5 mg. The tension is acting against it. That's going in the other direction. So that's the resultant force, i.e. my F, is equal to the mass of the particle, which is 5m. It gets confusing sometimes when they introduce m's, guys. Sometimes I put in m's unnecessarily, so just be real careful. It says that the particle has a mass of 5m, so that's the mass is 5m. Yeah, so the mass times the acceleration, which I'm told is 1/4 g. Therefore, I know if I rearrange, I'm going to get that T is equal to 5 mg minus, this is essentially 5/4 mg, which hopefully it's one of those questions that's kind of nice because it tells us what the answer is anyway. When I put that in, 5 wholes take away 5 quarters will give me 15 quarters mg. Job done. Right. Now I'm asked to find, let me just make this a bit smaller, group. Now I'm going to look at part B. So part B, find the value of K. Okay, so now I'm obviously going to have to look at particle B because it concerns K. So let's just look at those ones there. I'm just going to look at the forces acting on B. Remember, this tension doesn't apply to B. This applies to the pulley, yeah? So I'm just looking at the forces acting on B. And then I'm going to resolve for B. So for B, and then I'm going to resolve. I always like to resolve in whatever direction the acceleration is acting in. So if I resolve upwards, so i.e. I'm calling up positive, yeah? So I've got T minus kmg. That's me resolving the forces. So that's the resultant force is, let me just tidy that up a little bit. Is equal to the mass of said particle, km, times the acceleration, which I'm also told is 1/4 g. Right, let's make that look a little bit better. Well, I worked out from the previous part, or I was told, in fact, that the tension is 15 quarters mg. So let's just substitute that in. 15 quarters mg minus kmg is equal to, and then I'll just make this look a bit nicer. Let's call this 1/4 kmg. Now, oh, that's nice. So each of the terms have mg in it. So if I divide through by mg, all of the mg's are going to cancel. It's going to leave me with 15 quarters minus k equals 1/4 k. So let's bring that k over here and then solve to find it, and you should have got that k is equal to 3. Right, I'll talk through part C. So state how you've used the information that the pulley is smooth. In the event that there was any friction acting here, the tension in these two parts would be different. So your answer to that is simply the tensions are the same. Okay, that's part A, B, and C done. I'll do a separate video on part D. Thanks, bye.